Now we can see the classification of systems. On completion, the students can classify the continuous time systems based on property, and they can also classify the discrete time system based on properties. Now the systems are classified into continuous time and discrete time system, linear and non-linear system, static and dynamic system, time invariant and time variant system, causal and non-causal system, stable and unstable systems. Continuous time and discrete time system. Continuous time system. Continuous time system operate on the continuous time signal and produces another continuous time signals. This is the block diagram for the continuous time signal. That is represented. This is the representation of continuous time system. Discrete time system, it operates on discrete time signal and produces another discrete time signal. This is the representation of discrete time systems, or t into a of x1 of t plus b into a2 of x2 of n equal to a into y1 of n plus b into y2 of n, where y1 of n and y2 of n are the responses of x1 of n and x2 of n respectively. Nonlinear system. A system is said to be nonlinear if it does not obey the superposition theorem. The condition for nonlinearity in continuous time systems are t into a of x1 of t plus b into x2 of t is not equal to a into y1 of t and b into y2 of t, where we already know that y1 and y2 are the responses of x1 of t and x2 of t respectively. And if it is in the case of discrete time system, it satisfies this equation. Static and dynamic system. It is otherwise said to be memoryless and memory system. Static system. A system is said to be memoryless or static if the response of the system is due to the present input alone. Example, the continuous time domain y of t equal 2 into x of t, y of t. These are the two of the example in the continuous time signal, and these are the example in the case of discrete time domain. Dynamic system. A system is said to be memory or dynamic if the response of the system depends on factors other than the present input also. This is the example for the discrete time systems, continuous time system, and the third and fourth are the example for the discrete time systems. Time variant and time invariant systems, are shift invariant or shift variant system. Time invariant system. A system is said to be time invariant if the relationship between the input and the output does not change with the time. In continuous time system, it satisfies the condition if t y of t equal t of x of t, that is t of x of t minus t naught equal to y of t minus t naught. The case of discrete time signal, it must satisfy the condition y of n equal to t of x of n, that is t of x of n minus n naught equal to y into y of n minus n naught. It should be satisfied for the system to be time invariant. For the variant system, a system is said to be time variant if the relationship between the input and the output changes with the time. Continuous time domain, if the y of t equal to into x of t, that is t into x of t minus t naught is not equal to y of t minus t naught, should be satisfied for the system to be time variant. And the discrete time system, if y of n equal t into x of n, that is t into x of n minus n naught is not equal to y of n minus n naught, it should be satisfied to for the system to be time variant. Causal and non-causal system. A system is said to be causal if the response of the system at any instant of time depend only on the present input and present input, past input and past outputs, but does not depend upon the future input and future output. These are the examples for in the case of continuous time and discrete time systems. Non-causal system. A system is said to be non-causal if the response of the system at any instant of time depend on the future input and also on the present input, past input and past output. These are some of the examples in the case of continuous and discrete time systems. Stable and unstable system. A system is said to be stable if and only if it satisfies the BABO stability criterion. And BABO stability criterion for continuous time system is every bounded input produces bounded output, and the impulse response should be absolutely integrable, and it must satisfy this inequality. And if the BIBO system stable condition is not satisfied, then the system is said to be unstable system. BIBO stable condition for discrete time system, that is every bounded input is bounded output, and the impulse response should be absolutely summable, and it is given by this equation. If the BIBO stable condition is not satisfied, then the system is said to be unstable system. And these are some of the quiz questions for this classification of system. Thank you.